Hi grade 7s, today we're going to be looking at triangles and how to classify them. So there's two ways to classify triangles. The first way is to look at the sides, and then they are called scalene, isosceles or equilateral. Now you should remember from junior school that a scalene triangle, there are no sides equal. In an isosceles triangle, two sides are equal, and in an equilateral triangle, all sides are of equal length. You'll notice something else that's happening here is if you have an isosceles triangle, you also have two matching pairs of angles. So the angles opposite the equal sides are also equal, and the same for an equilateral triangle, the angles opposite the equal sides are equal, which makes all of those angles equal in an equilateral triangle. Now if we classify a triangle according to its angles, we're going to see that you get an acute angle triangle, a right angle triangle, and an obtuse angle triangle. So an acute angle triangle, all of the angles in the triangle must be less than 90 degrees, and the other triangles, we name them according to the biggest side. So although these have two acute angles, the biggest side is a right angle. So this is called a right angle triangle. And the same here for an obtuse angle triangle. It has two acute angles, but it's named after its biggest side, which is the obtuse angle. And then obviously the equiangular triangle, they're all three the same size, so it's the same as an equilateral triangle. So equiangular and equilateral are the same triangle. In question 1, it asks us to classify each triangle according to the length of its sides and its angles. So this is just practice. I always by habit label the angle first and then the sides, but some people say an isosceles right triangle, but I think it sounds better to say the angle first. So we're going to say a right isosceles triangle. This one is equilateral. Equiangular, we don't normally call it equiangular. We normally refer to it as equilateral. This one over here, it's obtuse, although it hasn't been given the size of that. You can see it's greater than 90 degrees, so it's an obtuse scalene, obtuse isosceles, because these are the same lengths. Right scalene, again, these haven't been given, the lengths of these sides have not been given to you, but you can see they're all three different lengths. And an acute isosceles. So please never measure the size of your angles or the length of your lines unless they tell you to. So normally we go by the markings they give us or by the measures they give us on the angles or the lengths of the sides. We don't normally measure things unless it says measure this angle and then classify it. Okay, so the next question says classify each triangle as scalene, isosceles or equilateral. So now we're just looking at the lengths of sides. First one equilateral, second one scalene, isosceles, and so on. On to question 3, it says classify each triangle as acute, let's just do that, equiangular, obtuse or right angled. So that's right, the right angle, obtuse, even though it looks, this is why I say we don't measure this, even though this kind of looks like 90 degrees, they tell you it's 91, so you have to accept what they give you. And this one, the same thing, they tell you it's 89, so we must say it's acute. Okay, one of the other facts we also learned in junior school is that the interior angles of a triangle add up to 180 degrees. So inside a triangle, if you add up all the degrees of the interior angles, it gives you 180 degrees. We use that fact a lot in maths. So this is just some practice on that. So to calculate what A is, we have to say 180 degrees minus 90 minus 40, and B 180 degrees minus 60 minus 50, C 180 degrees minus 85 minus 67, and so on. And those should all be straightforward for you. Okay, so In question 5, it's slightly more complicated, only in that they're giving you more than just one angle to solve for. So we go to the first diagram and we look at, firstly, what we're working with is a triangle. So we say A is the value of 180 minus 80 minus 45, which gives us 55 degrees. And then B, the other fact that we know is that angles on a straight line, they look like a protractor. They're equal to 180 degrees. So whenever you see a straight line and you're given one of the angles, you can subtract the other one from it to get the value of the missing angle. So B is 180 minus 80, which gives us 100 degrees. Then over here, we start off with A. Normally go alphabetically. I mean, sometimes you don't, but as a rule of thumb, it's a good suggestion. Look alphabetically. So we look just in this triangle first, and we can see that A is 180 minus 40 minus 20, which gives us 120. And then B, we're going to look at this big outside triangle over here, and we say that B is 180 minus 35 minus 20, which is this one over there, minus 40 will leave you with what's left on B over there for this whole angle up at the top here. And that gives you 85. Then the next question is nice as well. So we've got something, some of you went over this in constructions, but some of us didn't get there yet, but we still can go with angles in on a straight line, or we can go with angles in a triangle. So firstly, we're going to say that A, because of this angle on a straight line over there, is 180 minus 80, which is 100. And then you can use that A and this angle are on a straight line, which gives you 80 over there. Or if you did get to this in constructions, we know an angle that does that, this angle over here and that angle over there, will always be the same value, and we call these vertically opposite, vert-op angles. Okay, so either way that we get to that 80 degrees inside the triangle, we can then say B is equal to 180 minus 45 minus 80, which is 55 degrees. Another example here, when we are using two of the same letter, when we use the same letter twice in the same sum, then we have to make that the same value. So instead of saying A and A, like in the first line over here, say A plus 40 equals 180 because they're angles in a triangle. Instead, I can write that as 2A's equal 140 because I must take the 40 off of the 180 degrees. Then I divide both sides by 2 and I get A is the value of 70. Over here we have again our angles on a straight line. So we can say A, which is 70, plus B equals 180. So B is 180 minus 70, and that gives us 110.